This clip went around developer Twitter this past weekend. The person speaking is Boris Cherny, who built Cloud Code at Anthropic, on stage at an event on June 2nd. His words: "I don't prompt Claude anymore. I have loops that are running. They're the ones prompting Claude and figuring out what to do. My job is to write loops." That phrase, "write loops, not prompts," is the whole idea. And here's the thing the timeline hides. It is not as new as this week makes it look. Let's take it apart. First, clear up what we are talking about because the word loop is overloaded. One loop lives inside the model. The agent calls a tool, reads the result, calls another, until it is done. One session, one context window that keeps growing. The SDK runs that loop for you. We have a whole episode on it. This is the other one. You write a loop around the agent. It starts the agent, lets it do a chunk of work, then starts it again from scratch. Every iteration is a fresh context window. The memory of what has been done lives on disk, not in the model. That outer loop is what people mean by writing loops. He framed it as 3 stages of his own work, and most of us can place ourselves on this ladder. Stage 1. You write the code, autocomplete fills in the next few characters. The model is a faster keyboard. Stage 2. You run 5 to 10 Claude sessions side by side. You are still the one typing every prompt, just spreading attention across many agents at once. Stage 3 is the jump. You stop typing the prompts. The loop does that. It reads his GitHub, his Slack, his Twitter, decides what is worth doing, and sets the agent going. He calls this the transition for the rest of the year. The mainstream moment is this week. The technique is about a year old. A developer named Geoffrey Huntley gave it a name, Ralph, after the Simpsons character because it is gloriously dumb. Here it is in full. While true, cat the prompt file into the agent and loop. That is the entire method. One fixed prompt, pipe into Claude, over and over until the work is done. No framework, no orchestration library. The orchestrator is the shell. The point of the next few slides is why something this crude actually works. Here's the trick that makes a memoryless loop coherent. If every run starts fresh, where does continuity come from? The answer is the file system. A specs folder holds what to build, written down once so it survives every restart. An implementation plan holds the task list and the agent checks items off across runs. Git history is the record of what already happened, commit by commit. And the test encode what done means. So the next run inherits the bar. Put together, each loop is one fresh context window, doing one task, producing one commit. The repository is the memory. In practice, nobody ships the one-liner alone. It grows into a small funnel that Huntley describes as 3 phases, 2 prompts, and 1 loop. First, a requirements phase turns intent into spec files. Then a planning phase turns those specs into a prioritized task list. Only then does the build loop start, and it is the part that actually repeats. Each turn of the loop takes one task off the plan, implements it, runs the tests, and commits. The first 2 phases set the stage once. The loop is where the tokens get spent. So why throw away the context every iteration? It sounds wasteful. The reason is a well-documented effect people now call context rot. Models do not use a long context evenly. Reliability degrades as the window fills, even on tasks that are easy at short length. One concrete benchmark. On a long context retrieval test, GPT-4o scored 99% with a short context. Push the same task to 32,000 tokens and it falls to 70%. This shows up across models and across independent studies. A fresh short context, each loop is not a compromise, it is the point. This reframes what your job is. You're not writing the steps anymore. You're building the environment that lets a forgetful agent succeed and that rejects it when it fails. Tests fail. The run that breaks behavior. Type checks fail the run that does not compile. Lints and builds fail the run that cut a corner to look done. And the loop only lets the agent commit once it is past all of them. Huntley calls this backpressure. The slogan he uses is sit on the loop, not in it. Designing that backpressure is the actual skill. You do not have to write the bash yourself anymore. The pattern has been packaged. Anthropic ships an official plugin for it. Notice the mechanism. It uses a stop hook, the same kind of hook from our hooks episode, to catch the agent trying to exit and feed it the same prompt again until it prints a done string or hits a max iterations cap. Continuous Claude wraps the loop around pull requests. It opens a PR, waits for continuous integration, merges, and goes again. And CCSDD adds discipline. One task per run, test written first, and a separate reviewer pass before anything lands. Does this actually produce anything real? Here's the strongest single piece of evidence. Huntley ran this loop for about 3 months and built a working programming language he named Cursed. It has a compiler. It produces native binaries through LLVM on Mac, Linux, and Windows. His own summary is the line on screen. The most high IQ thing is perhaps the most low IQ thing. Run an agent in a loop. Now the honest caveat, because this channel does not do hype. Working is not the same as finished. He himself calls the standard library wild and incomplete. It is an existence proof, not a guarantee. This is where the honesty matters, and to his credit, Huntley is the one who is blunt about it. It is a greenfield technique. You can expect to get roughly 90% of the way on a new project. In his words, no way in heck would he run it on an existing codebase. It can leave you a broken, non-compiling repository. Some mornings the move is to reset hard and let the night's work go, and a bare loop has no stopping condition, so cost runs away if you let it. The max iterations cap is the real safety mechanism, not an optional flag, one myth to kill. The loop does not magically fix anything end-to-end on its own. The self-correction that is real is bounded. It rereads the specs, it fixes until the tests go green. It auto-debugs after a few failures. That is the mechanism, and it has edges. Pull back and the handwritten loop turns out to be the small end of something much larger. Anthropic's Institute published a piece in May on AI automating its own development. They report that more than 80% of Anthropic's production code is now offered by Claude, that engineers shipped roughly 8 times more code per quarter than in 2024, and that success on open-ended tasks went from 26% to 76% in about 6 months. Say the honest part clearly. These are Anthropic's own numbers about Anthropic, not independent benchmarks. And writing a bash loop is not the same thing as a system redesigning its successor. It is the same arc seen from the ground. The loop is where a single developer feels the early pull of that force. So, where does this leave you? You already understood the loop inside the agent. The shift this week is that there's now a loop around it, and writing that loop is becoming the job. If you want to try it, start where it is forgiving. A new repository, a spec you actually wrote down, tests that means something, and a hard cap on the iterations. Build the backpressure first, then let the loop run. Thanks for watching.